All right, Learning Target 9's video is about graphing a system of inequalities. So we're basically going to piggyback off what we did in Learning Target 5 and 7 and kind of put them together. In 5, we graphed one linear inequality, and in Learning Target 7, we graphed a system of equations. So if we kind of put them both together, a system of inequalities will have more than one inequality. Thus, the solution set will be the points that work for all of the inequalities in the system. Thus, we will graph all inequalities in the system on the same Cartesian coordinate plane and look for the points that work in the first inequality and in the second inequality and in the third, etc. So what I mean by that is this. Here's an example. X plus 3y is less than 6 and 4x minus 2y is less than or equal to 10. That's two different inequalities. So if we look back at Learning Target 5 notes, we would actually see the first one, x plus 3y is less than 6, already graphed. And you can go back to that video if you need to see how that came about. But towards the end of that video, I showed you a shortcut to graph them, which I'm going to use here. But we're going to need to graph these two inequalities on the same xy coordinate plane. So I'll start with this one, and I'll use blue to graph it. Then I'll use red to graph the 4x minus 2y is less than or equal to 10. Ultimately, though, we're going to be looking at where these two lines and their shading intersect, much like we did in Learning Target 1 and 2, where an and overlapped. But anyways, first, to graph the blue line, subtract x. 3y is less than negative x plus 6 divided by 3, and y is less than negative 1/3 x plus 2. So that's giving us a lot of information. Y-intercept 2, slope down 1 right 3, down 1 right 3, down 1 right 3, or up 1 left 3, and so forth. It's also telling us dotted line because it does not have the equal to, and it's also telling us shade below because it is a less than, all of which are older targets, so I know I'm going fast through those parts, but I'll grab a dotted line, keep it blue, and shade as it says y is less than, shade below. So there are all of the ordered pairs that work for the first inequality. In red, solve for y, put it in slope-intercept form. Negative 2y is less than or equal to negative 4x plus 10. This is slightly different than the one that I did in Learning Target 5. If you were to look back at that video, I changed the 6 to a 10, but ultimately it's the same. Divide by negative 2. So y is less than or equal to negative 4 divided by, wait a minute, just made a mistake. Almost. When I divided by negative 2, I need to flip that to greater than or equal to, just to keep the inequality true. Negative 4 divided by negative 2 is positive 2. So positive 2x minus 5. So when we graph this, we go down to negative 5. We basically ignore the previous blue line and its shading and think about graphing a new line with negative 5 y-intercept and slope 2. So think about ignoring the blue and just graph what's in red here. Y-intercept negative 5, down 5, up 2 right 1, up 2 right 1, up 2 right 1. Notice we graph the same point again there. Up 2 right 1, up 2 right 1, so forth. Down 2, left 1, down 2, left 1. This time it's a greater than or equal to, so it's a solid line. So we'll grab our solid line tool and red and graph that line. And then shade. According to this, y is greater than or equal to, so shade above. Shade above. And that represents all of the points that work for the second inequality in this system. So now we interpret using the words we set up here. We're going to have our final answer look for the points that work in the first inequality and in the second inequality. Since there's not a third, we're just looking for what points work in both. And that's going to be where they overlap, where the blue and the red shading is overlapping. So I'll just pick a different color, black, to really accentuate that these are the answers that work in this system. So really and truthfully, we need to take an eraser and go back and erase any of the shading that doesn't overlap over here. Erase all this shading over here, so that our final answer only has what is shaded that works in both inequalities. So then, a few interpretive questions. We're only going to have this one example as kind of our make-up notes or watching this at home. If you need more, we'll work on them in class. But the final few interpretive questions are, do these points work? The first point I would ask, does the point -3, +10 work? Left 3, +10 would be up here. Yes, it works in the red, but does it work in the system? No, it doesn't work in the system because it's not in the ultimate final shading. So, no, this does not work for our system. Next question, does the point 3, -5 work? Go right 3, down 5, 1, 2, 3, 4, 5. Again, I use blue because it was in the blue shading. Yes, it works for the blue, but not in our system. All right, and then finally, does the point -5, -1 work? So left 5, down 1. So where would be 1, 2, 3, 4, 5, down? Right here. Kind of hard to see. Definitely in the shaded, so yes, that works. And ultimately, a couple more. Does the point 0, -5 work? 0, -5 is on the red line, 0, -5. So does it work for our system? Yes, that's a solid line, and the shading overlap there, so yes. What about the point -2, +1, I'm sorry, -0, -2. There we go, 0, -2. What about the point 0, -2? It's on the dotted blue line. Dotted means they don't work, so no, it doesn't work. And the most tricky one, the trickiest one, the point where these two lines intersect, which is the ordered pair 3, 1. So the final question, does the point 3, 1 work? Well, let's see. It works in the red line because it's solid. It works it works in the red line because it's solid. It does not work in the blue line because the blue line was dotted. So let's go back to our definition. We shade all the points that work in the first inequality and in the second inequality. Does the point 3, 1 work in the blue inequality, the first one? No, so therefore it doesn't work in our system. All right, so that is graphing a system of inequalities, They can be other things than linear. This example is just linear. And they can have more than 2 inequalities. It could have 3. It could have 4. So that is the Learning Target 9 notes.